Hello. I'm Mikeal. I'm the Director of Evangelism at DigitalOcean, and I'm going to talk a bit about Node's past, present, and future. Because I'm super old, and I'm alive now, and I plan to be alive in the future, so I guess that makes me qualified. Also, great idea if you're speaking in the morning. Sponsor a whiskey tasting the night before. It'll really help attendance. Okay, so the best way to talk about, some kind of feedback there. Best way to talk about, in my opinion, the history of Node is to go back over the first Node program that I ever wrote. So I'm going to talk a bit about that. In December of 2009, this is shortly after Ryan Dahl sort of like released Node at JSConf.eu. Jan Learnhardt, who is a good friend of mine and had run JSConf.eu, he asked, like, has anyone actually written an HTTP proxy yet in Node? And if you watch that first demo that Ryan Dahl did of Node.js, a proxy server is like the most obvious thing to write with it. It's got all these great HTTP primitives, it's streaming by default, it just totally makes sense. And when we looked around, like, nobody had written one yet, and I was like, oh, that's interesting, maybe I can play with that. At the time, I had written this thing called Windmill. It was a competitor to Selenium. It didn't win, obviously, because you haven't heard of it. But but before Selenium had WebDriver and could kind of like work in a privileged space, Selenium and all of the test tools were working in unprivileged JavaScript and sort of keeping things in an iframe. So what we did with Windmill was we created this like insane, crazy advanced proxy that would return forwards to the same domain for every remote domain that you got, and then try to keep track of where all these requests came from and where they need to go. So basically, it tricked the browser into thinking that it never left the same domain and you could follow the same domain security policy. So I had spent about 3 years working on this. It was like 10,000 lines of Python code. It had like a higher, we also used a bunch of dependencies like a higher order HTTP lib plus like thread safe fixes for it. We had a special socket server. We had special threading library that could actually be killed. And to make your test run faster, I'd written just every possible optimization that you could do into this thing, like crazy keep alive pooling and all this awesome stuff. So I was like, great, I'll try out this Node thing. I'll write a little proxy server. That sounds like fun. So 2 hours later, on a Sunday, I actually had a fully functional proxy server. So this is what Node looked like way back in the day. Okay, so you require sys. That doesn't exist anymore. Then you've got, surprisingly, the http.create server call is still identical to what it is today. It's one of the few things that's actually still the same. We didn't have this sort of rec and res as the standard variables to be passed into that yet. Like, that wasn't really available in the documentation, and it wasn't what everybody was using. So I was still from Python, so I'm using like these variable names with underscores in them here. But if you look inside of the server, the first like 10 lines is just URL parsing, because Node didn't have an URL parsing module yet. So I'm just parsing that by hand, ripping out the server, or ripping out like what the remote server is and what the path is. When you get to this http.create client call here, this is also, it's still technically in core, but you shouldn't use it anymore. And I think we've even changed the documentation to not reference it. But what you would do prior is that you would create this HTTP client instance, and then you would call methods on it for each HTTP method. So if you look at this line here where we're doing client request.method.toLowercase, that's just so that we can like get at whatever that method is on top of the client request. So that'll give us this request object now, and then that's the actual HTTP request. So if you look at the very bottom here, client request.addListener. So that's an event emitter. We didn't have on yet on event emitters. You had to do this long add listener call. And then we're sitting on body events. So that doesn't exist anymore, but these were basically like the precursors to chunks and streams. Then we have, so on each chunk, we send that chunk to the proxy request using this send-to-body method. So obviously, this is like only happening in the HTTP API. There's no other API that has a send-body call on it. This is the second half of the proxy. So proxy request.finish. So we don't listen for end or listen for like an event when things are done. No. We have this finish function that we pass a function that then gets the response object when it's done. Also, it's not finished. It only got the headers. And like once it gets the headers, it gives you this response object. So, okay, so that doesn't make any sense, but whatever. So send header, this is like a way precursor to write head before we knew how to name things. Now, if you look at the encoding that we're doing here, we're trying to pull out the content encoding, and then for a few types, we're just going straight to binary. So a few things you have to know about this. One is that binary does not mean buffers or typed arrays. None of that stuff existed in 2009. So these are actually JavaScript strings with binary data encoded into them. It was horribly inefficient and really gross. And in fact, if you got Unicode or ASCII data and you tried to use this binary encoding format, it would actually mess them up, and there was all these bugs in it in this earlier version. So that's why I have to pull out if it's ASCII or Unicode and set that as the body encoding, because there's all these bugs if I don't. So then on that response, we also have a body event and a send body. So at least the HTTP client interface and HTTP server interface are somewhat unique. They have like some of the same events and some of the same send calls. Except for on the response, we wait for a complete event, so we don't do this finish thing. And then on the client response, we call a finish method, which does something entirely different than the finish method from the proxy request. And it has an entirely different method signature. Awesome. I think that one of the goals of Ryan's early release was just to be really inconsistent. And then, so then we listen on a port, and then listen didn't have a callback, so like we just hope that when we try to access the server, it's listening by now. And then we do sys.puts, because console.log would be obvious, and people would actually find that. So that was our early console log stuff. So this, by today's standards, this is pretty gross, but compared to my Python proxy, this was 50 plus lines of code versus the 10,000 that I had spent writing an efficient proxy in Python. The other thing that I noticed as I was developing it is that when I would run it and I would hit Control-C, it would always die. I don't know how much Python you've written, but Control-C is sort of advisory in Python. Like, it takes that under advisement, and then it may or may not decide to kill that process depending on what it's doing. And so you end up wrapping all of your logic in like these extra threading and extra sub-process modules that like are slightly more killable. So that was really nice, but like that's really awesome, but there's no way that this is faster than this Python proxy that I spent like 3 years optimizing. And then I benchmarked it, and it was way, way faster. Just way faster. It was also more reliable. I could kill it. I could bring it up really easy. It was simpler to reason about. Like everything about it was better. And so it was at this point, even in Node's infancy, when it was like half broken and fairly inefficient, that I just decided that I wasn't going to write Python anymore. Because everything that I'd done up to that point, I could see would have been easier if I would have had Node at the time. And that was sort of problematic right then, because I was sort of employed by Mozilla to write Python. So I was like, I'm going to use this Node thing instead. And they're like, what? And I'm like, yeah. OK, so a few months later, so 3 months after that, in February of 2010, this is what that program looks like. So now we have an URL module, thank God. So now we can parse URLs without doing it all by hand. That's great. So that gets rid of like 8 lines of code in the beginning of the server. We don't have that finish function anymore. Finally, great. Ryan realized that was a bad idea. We now have a response event, much like we do now, actually. That still exists. We also now have so we still create this HTTP client object, but we call a method on it called client.request, and we pass it the method. So now we don't have to do this weird HTTP method lookup as a property of it and stuff like that. Well, you notice the client response write header method. So we're nearing write head. We're getting close to where we are now. Now I can set I can set body encoding to binary, and it just works now. There's no more weird bugs, but this is still binary encoded strings. This is not buffers. We don't have real binary data yet. So now on response and on client request, you can see that we have data events, we have a write method, we have an end event, and you can call close on them. So a more or less like unified interface. We're getting very close to streams in this. You can't see it here, but also the FS method, like the file system stuff, is also calling these. Another thing you don't see here, and you don't see in the last example, is that the first example was actually written when proxies were still in core, or sorry, not proxies, promises were still in core. A very early, horrible version of promises were there. It's just that none of the streaming stuff actually touches promises. But by this time, promises are actually out, and we have a more or less unified interface around things that have like iterative data coming out of them, which is really cool. So then about 4 months later, in July of 2010, this gets even smaller. So as you can see here, this was when I started to get more and more involved in core. Now that we have this unified interface for data and end and close around like file system objects and HTTP objects and socket objects, I put a little utility into sys called pump. So sys.pump would take a readable stream and a writable stream. It would just send all the data together. This is really important once we fixed flow control. So how many people here have like used streams and know about streams? Like hands up real quick. Okay, so about half. So if you don't know what streams are, Node has a unified interface for a file handler, a socket, an HTTP call, something like big binary data coming out of a database. Anything that you want to get a lot of data and you're not going to take it all into memory at once, you're going to get it iteratively. There's a really unified interface around that. And one of the most important things that it does is that when you put all these things together, when you line them all up and you say like this sends to this, sends to this, sends to this, there's also flow control the other way. So if you have this giant file and you want to send it to a really slow mobile client, the mobile client's going to say, I can't take any more data, can you wait a minute? And we're not going to be pulling, and then that's going to make it all the way back to the file system and say, hey, don't pull any more data off the file system for a minute until this guy resumes. So managing all of that sort of flow control was starting to get a little complicated in line. And so sys.pump started to make it really easy, where you would just take these two things and put them together, and it would stood up the pause and resume logic for all the flow control, and also all the data would make it, and end would work and all that. So this was like a great addition to have. Also, we're to write-head now, so we're actually at like the modern response interface. Yeah, modern client response interface. So yeah, things are really looking up. And I mean, now we're at half the code that we were 9 months ago for the same demo. So things are pretty light now for about 9 more months. A lot of other changes are happening. Not a lot of stuff changes that like sort of modifies this. But Ryan, like at this point, I had already written requests as like a sort of module that people were poking around with. And Ryan started to clean up some of the API inside of core and get it a little terser. So you can see here we no longer have the create client call. We have an HTTP.request method that just gets us right to that HTTP client request object, rather than an HTTP client object that then gives us a new request object. So we get rid of a line of code. Things are starting to look just a bit cleaner. Also, this was genius. Ryan took that sys.pump code, revved it up a little bit, and put it on a readable stream in core that everybody can subclass. So now every readable stream among core and among userland just sort of like inherits from this readable stream in the streams module, and that has a pipe method on it. So now readable streams just have a pipe method, so you say readable.pipe to a destination. So it's starting to look a little bit more like Unix programs. It's starting to be a little bit cleaner and more and nicer. Also, we have console log. Yay! People who come to Node know where the fuck that is now. Instead of just being like, why is there no console? This is supposed to be JavaScript. So then just a few months later, in July of 2011, I got a one-line patch into core. And this one-line patch that I put into core, it was in the pipe method inside of core. So it's on all readable stream pipes. And at the end of piping, what it does is it just emits an event on the destination that says, a pipe event, and it says, this is the source that is being piped to you. So if you think about these two streams that are being stuck together, now that one of them has a pipe method, it knows like the object that it's going to send data to, right? You can make that your own method and then call into the prototype method, and then you know who you're sending data to. But you don't actually know who is sending data to you. You just get these write calls of these chunks. You might get like pause and resume call, but you never know what stream or what object is sending that data to you. So with this pipe event, now an object that is readable and writable, right, knows what its input and its output is. And it can start to look at that and do kind of more fancy-ish stuff. So at this point, I revved some of the code inside a request, my HTTP client library, so that it would be much more aware of the input and output that it was sending to. And if you take an HTTP server request and an HTTP server response, and you pipe them to an HTTP request client call, well, you obviously just want it to be a transparent proxy. So now, like this is down, I mean, inside of the server, we're down to 3 lines of code where all I'm doing is saying like, oh yeah, here's my HTTP client, be a proxy now. And if instead of being a proxy, I send it a file, like say I send it I take an FS stream and I pipe it to request.put and say put something into this remote web interface, it's going to look at like the path and look up the content type extension and then set the right content type header. So we can be a lot smarter than just being like sending these opaque data chunks around. We can actually like really understand our inputs and outputs and write really flexible but still pretty easy to read interfaces like this. So then about 4 months later in November, I don't remember who added this, but I know that Ryan was a big advocate for it. We made it so that pipe would return the destination stream. So it doesn't return self or this, it actually returns the thing that gets passed into it. And this is just so that we can write things that look a lot more like Unix pipes, right? Because you do like this pipes to this, pipes to this, pipes to this, and they're just in one line. So now we can do rec.pipe to request with the rec URL, and then pipe it to response all in one line, and it's all very clean, and this is it. So I think I made the right decision to stop writing Python, because I mean, in 2 years we brought 50 lines of code down to 1, and it's actually a lot more reliable now. Node's about 10 times faster at this point than it was 2 years prior. And now also, about this time is when we have NPM, and we're starting to see an ecosystem flourish, and it's all awesome. So this is where this example lands, and now we're going to start talking about Node in the present day. So this is data from modulecounts.com. They just try to keep track of, I knew it would do that. It cut off the fucking numbers. So everyone's at 0. So the top line is 80,000, and the one under it is 60,000. So if you look here, the 2 purple lines at the top, the one on the very top is Maven, and the one right under that is Ruby. So this is the absolute number of modules. And you can see that Ruby and Maven are growing pretty quick. This light blue line that's going really fast as of like the end of 2011, that's Node. And if you look at the current growth trends, it's going to surpass Ruby probably sometime this month, and it's probably going to surpass Maven sometime next month. So that's just an absolute number of modules. There's a few things about this data that kind of suck. So if you're trying to quantify growth, it's really stupid to look at an absolute graph because everybody can only go up. So that's not very good. Also, a Node module is probably not the same size as the average Maven module. And so if you want to try to quantify growth, it's not apples to apples. It's not apples to oranges. So one thing that you can do instead, what this does is it looks at every quarter of growth, and it takes the number of new packages added and charts the percentage of the existing system that represents. So if you grow by 10%, we put 10% on the chart for that quarter. The thing that I love most about this data is that if you go back far enough into the past, you see that every ecosystem has a similar curve, right? So they start out at like 10 modules, and they add 10, and it's like 100% growth. And then it sort of slopes down really nicely, and they level off. And one of the interesting things about them leveling off is that you realize that they're not so much in competition with each other. There's so much new growth happening in open source, so many new people coming to programming, so many people coming to open source programming, that everyone is growing, and nobody's really stealing stealing users from somebody else. If we were stealing users from somebody else, you'd see huge drops in one of these lines, because one of these just wouldn't be able to keep up with its growth percentage. But actually, most of them are fairly leveled off, except for the new ecosystems. So on the top, you have the newer ecosystems. Node is the green line, and the red line is actually packages from PHP. So PHP's been around forever, but they didn't get a package manager until like last year. So I don't know what the hell they're doing over there. But so you can see that Node is actually starting to level off now. So it started out really huge, and now it's starting to level off in terms of percentage growth every quarter. The crazy thing is that as it's leveling off, it's still leveling off at about 2.5 times Ruby and about 3 times Python. So the growth that it's experiencing, like even as a percentage of its whole, appears to be somewhat sustainable, and also is just dwarfing everything else that's going on. I have a whole different talk where I can talk about like what is growing and what that growth looks like, and what the engagement trends look like. A good percentage of that is actually front-end tooling. So a lot of like front-end tooling growth and engagement is happening as part of that line, especially in newer quarters. So like this last quarter, about a third of the growth in Node was in front-end tooling. Not just Grunt, but a lot of Grunt stuff. Okay, so why are we so lucky to be the fastest growing ecosystem? Like, what's making people, one, publish way more packages and also come to Node and contribute to the ecosystem and build so much stuff? And it really comes down to 3 patterns. We have 3 compatibility patterns that allow Node modules to be like Legos, okay? So we've got the standard module pattern, preferably just a function. So take note, if you publish a module, please just make the export a function. And if you have other properties on it that you want to expose, just add them to the function. But make whatever the default behavior is be a function. If you look at all the most popular modules, they all follow this pattern. Their main export is just a regular-ass function. So that's great. The standard callback pattern, so n number of arguments and then a function. That function takes as its first argument an error, so you have to deal with the error. You don't have a choice. And whatever the result is as the second argument. Sometimes APIs will have multiple result arguments, but it's actually really rare. It's like less than 1%. This pattern is really important because it scales down very well. So you can talk about callback hell all day, and you can talk about all these alternative ways to manage flow control, but when you want to do one thing and you want to do it really simply, and you want to show it to somebody who hasn't invested in your pattern and doesn't want to learn it, they don't need to know anything else about JavaScript except what a function is in order to use this pattern. So it scales down very, very well. And it also forces you to boil down the solution to whatever problem that you're solving down to just an error or a result, and just a single function call with a few arguments. That's really important. Like, that's more important than all of the advanced cases, because most people won't hit the advanced cases if they can't figure out how to do something simple. You don't get to callback hell, you don't get to learn promises or generators or whatever until you have enough time with Node to even experience that problem. And this makes the simplest case really easy. The vast majority of popular modules right now in the Node ecosystem follow this pattern. If you don't follow this pattern, there's a huge tax on what you export not following it. And I'll talk a bit more about promises and generators in a minute. And then we have the stream pattern. So I've already talked about that quite a bit, but basically I can give you a module, and then the return value from that function that you pass in whatever arguments to will be a stream. And then you can pipe that stream to different people. And because we're all following the same stream interface, anybody can pipe their stream to my stream, and my stream can be piped to anybody else's stream, provided that you have the right writable and readable stuff on them. You don't, like, the reason that Legos work, right, is that the top of the Lego and the bottom of the Lego follow a standard. And in between, it's Indiana Jones or Star Wars, right? Like, there's no consistency. There's not. So you can do anything in between these patterns, provided that on, like, at one end and at the other end, you follow them. And that's why we have such a huge growing ecosystem. So the future. Okay, so I promised that I'd talk about generators a little bit more. The best way to understand the future is to really look at the present. So this is a library called Co. TJ Hollowaychuk wrote this. It's a generator library. So this is much more interesting than anybody's done in terms of like flow control and promises prior to this. One of the reasons is because it's not trying to compete with the compatibility patterns that we just talked about. So for the longest time, if you were using promises, a lot of like generator libraries, a lot of people publishing alternatives to all these patterns, like crazy stuff like Streamline or Fibers, like they're trying to compete with fundamental Node patterns and fundamental Node compatibility patterns. What Co does is Co gives you a way to write generators and wrap up anything that comes out of the ecosystem that's in a callback pattern into a generator, and also take what you write and export it as something that everybody else can digest and not really care about the fact that you're using generators. So in the block here, you can see that Thunkify is just a module that takes any function that follows the standard callback pattern and will basically turn it into a generator. Or turn it into something that can be yielded, right? So right here, we actually have a sequential use case and a parallel use case. So if you write sequential yield statements, they're going to happen one after the other. If you put all of the co-rows into variables and then you yield them all in one array, they're actually going to happen in parallel. And you can see that with co, you just pass it your generator, and then you can call it right away, and then that will actually run it. But also, co's return value, like that function, follows the standard node convention. So here's like a generator exec command, so we can exec pwd here, and then you can see that we just pass it a function with an error result. So this is really, really cool because it means that we can use generators in all of our module, all over all of our code, and then we can still export a function, and nobody knows that we were even using generators. It follows the same compatibility pattern that everything else in the ecosystem follows. So there's no more tax on using generators. You're not opting out of the rest of the Node ecosystem and the 70,000 modules that are all compatible with each other as soon as you use it. You're free to sort of use generators as much as to your heart's content, and then you can publish things that everybody else can use. And you can use everything from everybody else. So this is really interesting. And I hope that we see this with promises eventually as well. And people stop trying to export promises because nobody's going to do that. Hopefully. We'll see. OK, so that's one interesting up-and-coming pattern that I think is going to be a big deal. Right now, so with Node 010, you have to recompile it to get generators. With Node 011, which is currently unstable but will be Node 012, you can get generators with just a flag. But that's still, it's not default. And so I don't think that this pattern is, co is really going to take off until it's just in there by default. And it shouldn't be that long until that happens in V8. But when it does, I think that it's got some legs. So going way, way back to one of the earlier examples, when I talked about the one-line proxy, we have this stream that is smarter about its inputs and outputs than just an opaque data stream. And when I first did this, I thought that a bunch of other people would sort of pick up on that pattern and go for it. But I think people didn't really understand it, so they mostly didn't. So I wrote another library called Filed that followed this pattern. But not until recently have I started to explore new use cases. So I have a library called Response. And Response is basically a request, but for HTTP responses. So it gives you a very similar API. What we're doing here is you just take this FS stream, you pipe it to a response object, and you pipe that to an HTTP response. What it's going to do is it's going to look at the path. It's going to set the right content type header. It's going to set any other headers that you might care about. You can also tell it to compress that. So you can have it turn it into a gzip stream and set the right gzip headers on it. You can tell it to gzip or deflate, or you can just pass it the request object and it'll look at the headers and figure out which one that it should probably do, or maybe not compress at all. So this is a lot of stuff that web frameworks will handle for you, but if you don't want to pull in a whole giant web framework, you just get this. Or you can start building web frameworks on top of this. This is pretty interesting though. So we have the streaming case. We have I'm sending you data iteratively, blah, blah, blah. It's a lot easier to say, OK, I wrote a transform stream. I wrote a stream that can handle iterative data. Now make it handle just here's a bunch of data, write it right away. It's really easy to scale that API down. So in the first call here, we have response.html, which just sets all the proper HTML tags. And I could pass that a string that I just write. I could pass it a string from a templating engine that I grabbed, whatever. And for that, because it's not happening iteratively, because we know the length of it, it's going to set the content length and do everything right. It's going to set an e tag because we know what that's going to be. You can also, say you have a file and the file doesn't have the right extension and you want it to set all the HTML headers properly, you just pipe it to response.html and then that's all taken care of for you. You have a JSON API, you have a text API. It's all relatively simple. It's a lot of logic boiled down to an incredibly tiny API because this object understands its inputs and outputs, right? If I send this, I could also take this, I could send it to the response, and then I could also pipe it to a file, and it would write out that file and not try to set headers on it and do all that shit, but it will set the headers on the thing that's an HTTP response. So understanding inputs and outputs is really, really powerful. I'm going to try to go into how you implement this, but it's probably not going to work. It can get a little bit complicated. But if you look here, so this is a reduced version of the response constructor. So we initialize headers. We initialize a destinations thing. I'll get into that later. Headers is much more important at this time. We use stream.transform. So this got added in node 010. We now have a much simpler interface for creating streams that mutate data. It was really hard to write streams that mutated data, especially if you needed to go off and do I/O to mutate data prior to this, because managing the sort of like pause resume logic was really complicated. So it's a lot easier. I'll get into that a little bit more in a second. We listen for the pipe event, and then when we get a pipe event, we say, oh, okay, do all of the standard mutations that you want to do from the source to this object. I'll go into that function in a minute. The rest of it you can pretty much ignore. I mean, the view is just a string, so like if you write a string or a buffer to it as the first argument, it's going to wait until next tick. So it's going to wait until everything in the event loop like bombs out. That's so that you can pipe this to any other destinations before it decides to write it. And then it's going to end it and write that chunk. Relatively simple. OK. So transform streams give you this underscore transform method. If you're into writing Node, I really suggest that you play with transform streams. They're really fun. So it gets the chunk, like each chunk of data, it gets the encoding that data is already written in. So like if you do set encoding, you're not going to get buffers anymore. You're going to get like Unicode strings. And then it gets a callback. So now inside of that function, if you go past the omitted part, we have this internal push method. So that's essentially how you say, OK, here's the data that I'm pushing along. So if I was going to mutate this data, if I was going to change it a lot, I would push my new chunk of data that I've changed. In this case, we're actually just passing it through. So we just do this.push that chunk right away. Because we have a callback, though, we can go off and talk to a database or do whatever we want to, and then mutate that chunk, and then call the callback on it. And until that callback gets called, the stream's basically going to be in a pause state. So if it's taking a long time to do all these operations that it needs to mutate, it's not going to take a huge amount of data into memory because it's still waiting on one of those callbacks to happen. The underscore pipe method, basically we don't want to do any of the standard mutations on our destination objects until the first chunk is written. That's because you may pipe it to multiple places, so you don't want to do it just in the pipe method. You may wait until like you go off and do some other I/O operations before piping. So the best thing to do is just wait until the first chunk, and then basically handle all your standard mutations. Note that we're calling the same mutation function again, saying, well, now the source is this object, and the destination is each destination that I'm being piped to. OK, so here's the mutations function. This is where the magic happens. So if the source has headers, we want to set those headers on the destination if the destination can have headers set. Remember that the response object itself now has to masquerade as both of these types. So it has a headers property. It has a set header property. So anything that's getting piped to it or anything that's getting piped out of it, it's going to pick up all of that data off of it. So if you want to, just like if you're proxying chunks of data through a proxy stream, and you have to hold that chunk and look like a stream in between, if you want to take data, like HTTP data, off of one and proxy it to another, you have to look sort of like an HTTP object. The same thing for if you want to proxy the path data. File streams will all have a path property, and that path is the path to the file in the file system. That's all you need to know for that part. And that's where we do the content type lookup and all that kind of stuff. And of course, like proxy status codes. So like if the source is a status code, just set it on the destination. So the interesting thing about, the thing we have to realize about this pattern and the big shift that it's making is that we're changing what pipe means. Because to date, pipe has meant send data, like send stream data. And what we're saying is pipe now means send this object. It means delegate all of the data that you can find from one object to another, which is a really powerful sort of object-oriented programming concept, right? we can now write like really complex like mutations and things that happen. So you can have like a streaming template library, and that template library can be aware of what content type it should be. And then that content type can be piped out to whatever destination that it has, right? If that destination should have that. And we get rid of a lot of like the crazy glue code, and we get rid of a lot of the like little utility methods that are in all of these libraries, because now pipe just handles that because it knows what that object is supposed to be. So that's all I got. I'm not great at closing, so I just decided to give away free money. Well, it's almost free money. It's DigitalOcean credits. So if you weren't at the whiskey tasting last night and you want DigitalOcean credit, like just hands up and I'll give you a bunch of these.